Okay, this is the second half of section 7.3. Okay, now you can kind of sort of see me. So I showed you how to do reduced row echelon form on your by hand. I expect you to be able to do it by hand. On the quiz, you will have to do one and you will have to show your work. It will take a while. It's a pain in the butt. I want you to understand the process. Now I'm going to show you how to do it on your graphing calculator. I would recommend checking them on your graphing calculator. So I've got this system of equations. This is the same one we did at the end of the last video, but now we're going to do it on the calculator. Plus y minus z equals 0, and negative x plus 2y minus 3z equals 7. I'm going to put this into my matrix. 1, -1, 2, and remember we call this an augmented matrix. 2, 1, -1, 0, -1, 2, -3, 7. So sometimes we can look at the thing to the left of the line and call it the coefficient matrix. Thing to the right, call it the solutions matrix. So I am going to flip over to my calculator, show you how to reduce row echelon this and get the answers rather quickly. So doing matrices on the calculator. There is a button, known as matrix. Second button right there, it just lit up in red, second matrix. I am going to edit matrix A, and I need a rows, columns, 3 by 4. Now I need to enter this matrix. Nope, I did that wrong. I guess enter takes me over. It might be faster to just hit enter. If I hit enter, I go across, and then I probably have to use a little less arrows. These are not the fastest things in the world to enter. Actually, I think enter. I don't know if I've ever done enter before. Just kind of takes you through this process. I think that's actually the fastest way, is just hit enter. So now I've got matrix A. To reduce row echelon this, I'm going to quit out of this. Doesn't matter that much, but I'm going to go second matrix again. I'm going to scroll over to where it says math. I'm coming up from the bottom here. Reduced row echelon form is RREF. Ref is row echelon form. Reduced row echelon form is RREF. And then I need to select matrix A. So I hit matrix again. I just go under the names, hit A, close my parentheses. And that gives me my results. So what does that mean? My first row has X plus 0Y plus 0Z equals -2. Second row, 0X plus 1Y equals 7. And Z, 0X plus 0Y plus Z being my third column, 1Z equals 3. Which is the results we got at the end of the last video. We're going to do another one. We're going to do example 5's equation. And then we'll put that into a matrix. Okay, so here is my new system of equations. This is example 5. This one's going to have infinitely many solutions, and I want to show you what the calculator puts in when you have infinitely many solutions. So I'm going to put in the matrix, and I'll edit. One, +3. Sometimes I have to hit enter twice if I'm not changing the value. This is 1. Okay, there I've got my new matrix. I can just go right back to matrix. I don't really have to quit. Reduced row echelon form. And it's our new A. I don't know what I'm doing right now. Okay, let's try again. Reduced math, reduced row echelon form, and let's grab matrix A. Maybe I did need to quit. Okay, so as I do this, my z's entirely cancel out. I cannot get to a true reduced row echelon form. We can see this. Anytime I can't get to a true reduced row echelon form, this is not working. This one had infinitely many solutions. Okay. It's equivalent to the original system. You end up here with 0 equals 0. If I ended up with something like 0 equals 4 in that circle, then I would know I have no solutions. Okay. So I can do one with 4 variables and 3 equations. In fact, I can't really ever solve 4 variables and 3 equations. Okay, so example 6, and I'm going to write it out, but is going to give me 3 equations, 4 variables, and that's never going to be enough to solve. So, oops, let's not put it into the matrix yet. X plus 2y minus 3z, and they're leaving a space here for w. So right here, I have variables. Well, I guess I'll do the second equation. 1, 2, 3, 4 different variables. If I only have 3 equations, this will always be infinitely many solutions. There is no way to have this work out to exactly 3 or 1 solution. Okay. An alternative method to do this is to use inverse matrices, the alternative to the reduced row echelon form. So an inverse matrix, we talked a little bit about finding it on a 2x2 by hand. We're not going to do them by hand. And I'm going to show you a little bit the theory behind this. So I can put this into a matrix with the coefficients. And that is really expressed as times xy. And if I do matrix multiplication, I can actually see that come out. And then that's going to equal this equal thing. To do this, To solve this, I can find the inverse. You cannot divide by matrices. You can find inverses. You can multiply by inverses. Inverse of a number is its reciprocal. So I'd be multiplying by the reciprocal. And because I multiplied the inverse matrix on the left side, I must multiply my other inverse matrix on the left side. The side does matter. Matrix multiplication is not the one where you can switch the order. Yes, 5 times 3 is equal to 3 times 5. We call that the commutative property, meaning we can switch the order in multiplication. You cannot with matrix multiplication. Because this one was on the left, this had to be on the left as well. These two inverses multiply to be the identity matrix, which is essentially like saying they multiply to be 1. They don't need to be there. That's just XY. To compute my matrix, I'm going to call this A, this B when I enter it in the calculator. So I'm going to do A inverse times B is going to give me XY. So I'm going to go back to the calculator screen. We're going to do that. I'm going to edit this one. I need a 2 by 2 this time. And it is 3, -2, -1, 1. Oh, -1 there. Okay, 1. And now we're going to do the same thing. I'm going to quit matrix and I'm going to edit matrix B. And that's going to be a 2 by 1. And that is the solutions matrix 0, 5. And I'll quit. Now I'm going to take matrix A. I go names, matrix A. The X inverse key is the first function of the one that's matrix times matrix B. Top one's X, bottom one's Y. Here, X equals 10, Y equals 15. That's example 7. That's pretty straightforward. Let's do one with a 3 by 3. You could find the inverse by hand. We talked about that in 7.2, but let's not. For a 3 by 3, it's possible to do it by hand. I have not taught you that, and I probably never will. It's kind of a big pain in the butt. If you go on to take linear algebra in college, you probably have to learn how to do it by hand, because you might have to do a proof with it. So A is going to be my coefficient matrix, and B will be my solutions matrix. So we go back, we're going to put it right in the calculator. Go over edit, 3 by 3, 3, -3, 6, 1, -3, 10, -1, 3, -5. Now we're going to go back here and edit another matrix. Now this one has to be a, I didn't want to edit this matrix. I want to edit matrix B. So you edit the one you want to edit. 20, 40, 30. Matrix A inverse times B. X is 18, Y is 39.33, and Z is 14. Okay. We're going to do a special application for parabolas, and we did do this last year in Algebra 2. But we're going to take up 3 points. A parabola is defined by 3 points. And we're going to use a system of equations to write those, to write the quadratic equation. Okay. Point A is -1, 5. B is 2, -1. And C is 3, 13. And in general, we know that a quadratic equation in standard form is y equals ax squared plus bx plus c. So I am going to take both of these 5 and plug in x and y. -1 squared plus b times -1 plus c. And that's going to give me 5 equals a minus b plus c. I'll do that for my next point, 2, -1. And that is -1 equals 4a plus 2b plus 1. No, plus c, 1c. My matrix will be plus 1. And if you can now tell maybe why I need 3 points, because I have variables a, b, and c that don't go away. And that is 13 equals 9a plus 3b plus c. I will put those into my calculator. And I've always been a reference of the I've always been a fan of the inverse matrix method. It's kind of my preferred. Most of my class last year preferred the reduced row echelon form method. So you can do whichever one you prefer. If it doesn't tell you, you can do whichever one you prefer. So I'm going to do the one I prefer. And that is 1, -1, 1, 4, 2, 1, 9, 3, 1. -1. Nope, -1. 13. So A inverse, because remember I'm taking B, I'm left multiplying by A inverse. So remember I had matrix A, if I go back to writing out what I started with, I had A times X, Y, Z. and we often do notate matrices with capital letters, equal B. And we did left multiplying by A inverse. And so that's what is here. And yes, that works every time. To me, that's easier for me to remember. Although the reduced row echelon form is pretty nice. It's pretty simple as well. So you can use whichever you prefer. I think most of my class last year preferred reduced row echelon form. So they didn't have to enter as many matrices. Fine. What does this mean? Means, so this is not my answer. The answer is not, it's ABC. Oh, that's not XYZ. That should be ABC for this case. That was ABC. And my answer is the quadratic equation. A is 4, B is 6, C is -5. And my equation is y equals 4x squared minus 6x minus 5. And that's the equation for my parabola. That is the end of section 7.3.